All right, so for now, we are going to discuss from where we stopped last semester. So we are at the second part of our chapter 4. All right, just a very quick revision that for chapter 4, there are two main parts actually. All right, so the first part, we are talking about the sampling distribution. And then the second part, we are going to talk about the estimation. Okay, so this is what we are going to discuss for today is the estimation part. All right, okay, so in sampling, in the sampling part that we learned in the last semester, we already have some idea about sample and population. Okay, so we are going to bring in the sample and population idea also in the estimation part. Okay, so let's have a look for the learning outcome for today. So for learning outcome 4.3, you will see that they want you to calculate the unbiased estimates. Okay, so unbiased means accurate. Estimates means the something that you just estimated, which is not how to say, not accurate, but you use some value to estimate another value, right? Okay, so unbiased estimates means they want to calculate the accurate estimate of a population mean and also the variance from a sample using either raw or summarized data. Okay, all right, so only a simple understanding of the term for unbiased is required. Okay, so now in sampling, okay, we talk about the concept of population and also sample. So a simple understanding on population and sample is population is a bigger group, right? A whole group, and then the sample is a smaller group taken out from the population, right? And then they realize that when you're having a sample, right, the variance of the sample will be a bit different because if you are having the mean of the sample mean, it is equals to the population mean. And then when you are calculating the sample, the variance for the sample mean, you realize that it is actually the variance of the population divided by n. This is something that we learned before. That means we get the sample value from the population. Okay, so that's the main idea in the sampling part. Okay, so for now in the estimation part, we are going to do the other way around. All right, so now you have all the sample value and you want to estimate the population. Okay, you want to use the sample value to estimate the population. All right, so now the problem is when you have in sampling part, when you have the population value, which is a big group of value, right? To estimate a smaller group of value, usually it is quite good and accurate. Okay, right? So which has no problem. But now when we come to estimation part, when you want to estimate the value by using a small group of value, which is sample, so the sample is a small group, right? And you want to estimate a bigger group value, which is the population value, usually it won't be so accurate, or maybe there are some bias. So our aim is to actually calculate the unbiased estimates. That means as accurate as possible. But of course, all these are by theory, by formula and theory. If you really try out in the real life cases, you will see that it usually still not so accurate one. All right, but by theory, right, the formula that we learn, we call it as unbiased estimates. Okay, all right. So now, this is what we want to focus now, how to use a small sample value to estimate the population's value. All right. Okay, so now let's start with some basic idea on this. All right, so last time we learned some distribution, right? We learned the binomial distribution, Poisson, and also the normal distribution. Okay, so all the parameter inside, we call them as population parameters. Okay, so if let's say we don't know the value of the population parameter, we can actually try to make an estimate, okay, for the unknown parameter. So the estimate is unbiased if the mean of large number of values is taken the same way, it is equals to the true value of the parameter. All right, so that means if let's say when you want to estimate a value of the population, okay, the value can be quite accurate if you try in the sample, when you collect all the values from the sample, right, you're using a large number of values that taken in the same way, and which is quite close to the original value. But of course, all this we don't know. That's why we call it as estimates only. All right, it is just an estimation. Okay, so whether it's accurate or not, according to the formula, it is accurate. Because when you try to apply in real life, usually it won't be so accurate. Okay, all right, but by theory, okay, or by formula, it should be accurate. Okay, all right. So you have to remember this when they ask you to do the unbiased estimation. In our syllabus, we mainly focus on two values. The first one is the mean, the second one is variance only. So we are going to focus on these two. All right, but maybe when you go to higher level of statistics paper, then they might ask you to estimate some other values. So for us, we only focus on mean and variance. All right, okay. Then now, when we want to do the estimation, okay, there are two methods. So there are two types of estimator. The first one is point estimator. Another one is interval estimator. Point estimator means you will get a single value in your calculation to estimate the value. Your final answer is only one value, like a single value. So we call it as point estimator. And then for interval estimator is your final answer for the estimation. There are two values. It is in a range, form and interval. So that's why we call it as, usually in the formula that we are going to use to learn, the method that we are going to learn for the interval estimator will be the confidence interval. Confidence interval. So that means the value is in a bracket form with two values, so we have to calculate out the A and B. Okay, and then for point estimator, your answer is only a value, which is a A only. All right, so how to calculate all the estimator, then we are going to discuss it now. All right, okay. So let us start. So some students they will ask me, can I know like how can I get the formula for the unbiased estimates for variance and so on? All right, so all the formula here, it is impossible to prove out by using any concept or idea. All right, so they actually create all these formulas generally by running a lot of experiments, taking a lot of samples, and they try to derive out the formula. All right, so without the experiments, right, I cannot show you how the formulas, how are you going to get the formulas? All right, so what are we going to do is like we learn how to apply it for now. Then in the future, when you go to a higher level already, then maybe only you learn the process, okay, of calculating or derive the formula for the unbiased estimation. Okay, all right. So now let's start. There are a few formulas in this case. So first, the unbiased estimate of the mean. Okay, and then you will see that in our notes, we put the mu with a cap. So this is to tell you that this is the estimation value of population mean. The cap here tells you that this is the estimation value. All right, if you don't want to write out, it doesn't matter. You will not be penalized any marks. Okay, all right, so it's very easy. The unbiased estimate of the mean, the formula is very, very straightforward, which is the original equation, okay, for the mean that you learned before, which is summation x divided by n. Okay, so last time you learned, right, population mean is equals to sample mean also, right? When you take a sample out from the population, the mean value is always the same. So same thing happen here. When you want to estimate it, you also use the original value, which is summation x divided by n. Okay, so the other part is the unbiased estimates of the variance. Okay, so in A-level syllabus, the formula, the symbol for unbiased estimates of variance, we are using S square, okay, as the symbol. All right, for some other reference book, they will use sigma square, then with a cap, also can mean as unbiased estimates. All right, so to just to make sure that I don't confuse you all, then I will just follow what is given in the textbook. All right, in the A-level syllabus. So the S square is actually the unbiased estimates of the variance, which is estimation value of the variance. Okay, all right, so let us start. So for unbiased estimates of variance here, there are three formulas that you can use. The first one, okay, is 1 over n minus 1 summation x squared minus sigma x squared divided by n. So the second one is 1 over n minus 1 summation x minus mean square. And the third one is n divided by n minus 1 multiplied with sample variance. So what's the meaning for sample variance here? So sample variance here is actually the original equation for the original value for the variance that we learned before, which is sigma square. Okay, and then or sigma s square. Then you're having already summation x square divided by n minus the summation x divided by n and then square. Okay. All right. So after you calculate this value by using the old formula that we learned, then only we apply it here to become n divided by n minus 1 multiplied with the value. So it becomes the estimate value of variance. All right. So there are some confusion here actually. So some students will ask me, hey, I thought that last time when we learned the sigma square should be our population variance, right? Okay. So now in estimation part, when we are talking about to estimate the population, right? So the sample variance, when how you calculate a variance for a small group. So when you want to calculate the variance for a small group, we still use the same formula that we learned at the very beginning of A-level syllabus, the steps 1. All right. So although from the from the symbol, you can see that it seems like it's a population variance, but the meaning is the variance that you calculate from raw data, like the groups. Okay, that means you have the data and then you want to calculate the variance, right? So this is the original formula that you have. Okay, so in this case, they call it as sample variance because they treat as a small group, right? Then and you want to use this value to estimate the variance for the population. So there are 3 formulas for variance here. All right, so what kind of variance formula should you use in the exam? It depends on what kind of data they give you or information that they give you in the exam question. All right, so generally 3 equations here are equally important. And if I'm not mistaken, they only provide you 1 formula in the formula booklet, which is this one. I think the rest they didn't provide you, so I think you might need to remember yourself, memorize it yourself for the other 2 formula here. I'm not so sure. Please double check it for me. You can refer to the formula booklet. All right. Okay, so in general, these 4 formulas are the point estimator. That means when you apply this formula, the final answer that you get, there's only 1 value. So we call it as point estimator. So again, just to sum up, this one is the unbiased estimate formula for the mean, and these are the unbiased estimate formula for the variance. That's it. So this is what we have for this part for point estimated. Okay, all right. So let's have a look for example 15. Okay, so actually example 15 consists of part A and also part B. What I want you to do now is maybe you can pause the video first. You try at part A and part B first on your own to see what is the difference between these 2 questions. And then you can also at the same time try to figure out what is the difference between these 2 questions. Okay, and then you continue with the discussion in this video later. All right. Okay, so for me, I will straight away continue the discussion here. Okay, so for example 15, there are 2 parts. So here they say there are 9 CDs, and then they record the time side. Okay, the time in minutes are given below. So they want to find the mean playing time of the 9 CD and the variance of the playing time. So you're having this 9 CD here, and they want you to calculate the mean and also calculate the variance. So how to calculate the mean? All right, so for the mean, you can use population mean if you want. You can use sample mean also if you want. It doesn't matter. So in exam, if you find out that you're not so sure what to use, right? Then you just write out the mean, which is the safest way. Okay, so for me, actually, I don't think that the symbol, if you put it wrongly, they will penalize your marks. All right, so you can just write whatever you want. Okay, all right, so maybe I just write out the mean better. Okay, so to calculate the mean from AS paper, AS stats 1 paper, I think you should know lah. The basic calculation for mean is you add all the values together. Then after that, what you need to do is you need to divide it by 9, right? Okay, so divided it by 9. Then after that, maybe I can show you the summation of x, 522 over 9. And after that, you'll get the value 58. Okay, and then to calculate the variance, you need to have the summation x squared. So summation x squared means 49 squared, then plus until maybe 63 squared divided by 9, then minus the mean square. So mean I'll use 522 over 9 squared. So all these are the basic formula that we learned previously, right? Okay, then the summation of x squared that I get is 30550 divided by 9, then minus 522 over 9 squared. So you should get 30.4. Okay, so this is very basic. That means when I give you some data, I just want you to calculate the mean and also the variance. That's it. So you use back all the original value that we learned last time. Okay? All right, then if I proceed to part number 2, part B. Okay, so here they said a student was doing a project on playing time of CD. She wished to estimate the mean playing time for CD so throughout the country, and she wished also to estimate the variance of playing time of CD throughout the country. So she took a sample of 9 CD and recorded their playing time. So the results are given below. So you can see that here they also have 9 CDs and all the values are the same. But when they try to explain these questions, you can see that there are some extra details here already. Because actually they said she want to estimate the mean value so throughout the country. So if you compare, she has only 9 CD and she want to use this 9 CD to estimate the mean, to calculate the mean for the whole country CD. So that means you want to use a small group value to estimate the large group value. So this is what we call as estimation. Okay, but if you refer back to part number A, they only tell you that I have 9 CD only. I'm not going to do anything with the CD. I just want to calculate the mean and variance. Very straightforward one. Okay, so this 9 CD in part number A is the whole population that I have. Okay, understand what I say or not? All right, so you look at the meaning of the question. So for part number B, very obvious, they want you to use the 9 CD to estimate the mean time for the whole country one. So a small group value to estimate a large group value. So we call it as estimation. All right, so sometimes the keyword is not obvious, but usually you will see the word like estimates, the word estimates. Although it is not obvious, but in the meaning, you can see that it's quite obvious that you want to use a small group to estimate the value for a large group. Okay? All right, so this is the estimation part. All right, so if let's say I start with part number 1, use the students' data to estimate the mean playing time for CDs sold in the country. So she said, okay, use the 9 CD here to estimate the mean for population. Okay, so this is the estimation question. So to calculate the estimated mean, what is the formula? So again, it is summation of x divided by n. So what is the summation of x? If you refer to part 8, it is 522 divided by 9, and therefore you get 58. Very straightforward. All right, so for part number 2, they want you to use the CD, the 9 CD small group to estimate the variance of the CD sold in the country to estimate the large group. So again, this is the estimation part. So to calculate the value for estimation of the variance, there are 3 formulas here, right? Okay, so maybe I use the most basic one, which is the first one, 1 divided by n minus 1. Then the formula is summation x squared minus summation x divided by n. Summation x bracket square divided by n. So 1 over n minus 1 is 1 over 8. Summation of x squared, right? You can look at the value that you get from part A, which is 30550, minus summation of x, which is 522 square divided by 9. So this is the first formula that I applied in the variance value. Okay, so if I continue from here, then I'll get 137 divided by 4, which is 34.3 lah, if I round up to 3 significant figure. Then this is when you want to apply the first formula. If you don't like the first formula, then there's another option for you. You can choose the third one. So the third formula is s squared is equals to n divided by n minus 1 multiply with the sample variance. Okay, so for this question itself, the 9 CD become a sample, right? Because it is a smaller group. And you want to use this smaller group variance to calculate the population one. So you can also use this formula, which is n9 divided by n minus 1, which is 8, multiply with sample variance. So what is the value for sample variance? It is the variance that you calculate just now on top. Okay, all right. Then you can substitute this value inside if you want. Okay. All right, so if you substitute the value here, but of course, you have to make sure that you put in the long value, 30.4, blah, 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 blah. Okay, so I just put 30.4, then blah, 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 blah. You will see that you should be able to get the same value, which is 34.3. Okay, so that's why they call it a sample variance for this 9 CD in this case, because in this particular part B, the 9 CD has become a smaller group, which is a sample. Okay, that's why in part A, when you calculate, you use the population value, the formula to calculate the variance, right? Okay, because in this example, part number A, the 9 CD itself is the whole group, is the population. That's why when you calculate, you'll get 30.4. But in this part number B, the population, sorry, the sample, the 9 CD here already become a smaller group, okay, compared to the population value that they want to calculate. All right, so for this case, here we define the X, the 9 CD here as a sample now. So that's why we put it as a sample variance and you can get the same answer. All right, so in short, you can see that I put a small note at the bottom of this part. Okay, so part A and part B are very similar. However, in part A, you are only interested in playing times of the 9 CD. Then for part B, you want to estimate the population parameter. So that's why part number B is the estimation question. So usually you look for the words estimate or unbiased estimation as a hint, okay, to apply this formula in this part. Okay. All right. So if let's say no problem, then generally we have done with our estimation part, the point estimator part. Okay, so example 16, 17, and also 18. You can continue it first. You can try it out first. Then in the next video, I will roughly discuss it with you. What are the answers and how you get the answer. But you can try it out first. It is not hard. Okay, it is quite straightforward. So I will discuss the rest of the example in the next video.